See, in this question, there is a boy who pushes this ring over here whose mass is 2 kg and radius 0.5 meter with the help of this stick. Okay, and this stick applies a force of 2 Newton on this ring such that this ring does not slip on this ground and it rolls on this ground with an acceleration of 0.3 meter per second square. The coefficient of friction between this ring and the ground is large enough such that rolling will always going to occur over here, and the coefficient of friction between this stick and this ring is given to me as P by 10. Then we have to calculate the value of P over here. So look, this is the ring over here. Its weight 20 Newton will be acting downwards like this. Ground will going to offer that I have a normal which I have taken as n dash over here. This stick is applying a force of 2 Newton on this ring like this. So I have taken the ground is applying a friction force which is in this direction F1, and I have taken the friction force applied by stick in this direction as F2. If these direction that I have assumed are wrong, then my answer will going to come negative, so there is no worry about it. And this ring is accelerating with an acceleration of 0.3 meter per second square in this direction over here. It is given in this question. So what I can write over here, applying the Newton's second law over here. So force in the direction of acceleration is 2 minus force in the opposite direction of acceleration is F1 will be equals to twice of acceleration, means mass into acceleration. This is the net force, that is 2 minus F1 in the direction of acceleration. This will be equals to ma. M is given to me as 2 and acceleration is 0.3. From here I will going to get the value of friction that is offered by the ground on this ring. It will come out to be 1.4 Newton over here. This force of friction is coming out to be 1.4 Newton. Now as this ring is not rolling over here, so the acceleration of this point O must be equals to acceleration of this ground, but the acceleration of ground is 0 because it is stationary over here. So acceleration of this point O will be 0, acceleration of O will be 0 if this ring is rolling over here. Okay, so acceleration of O will be acceleration of center of mass, that is 0.3 over here in this direction, minus r into alpha. Okay, that will be the net acceleration of this point. So I have written 0.3 minus r into alpha. This should be equals to 0. Putting the value of r as 0.5, I will going to get alpha as 3 by 5 over here. Okay, now I can write the equation of torque. That will be torque will be equals to I alpha. Now net torque, see the torque of this 2 Newton over here, the force, the torque of this force 2 Newton will be 0 as this 2 Newton is passing through center of mass of this ring over here. Okay, so I am taking torque about that point only, that is about center of mass. So torque of this force will be 0. There will be only torque of this friction force that is offered by the ground and this friction force which is offered by stick. Now torque of this friction force which is offered by ground will be F1 into this perpendicular distance, that is radius, and it is rotating this ring over here in anti-clockwise direction which I have taken positive. So it will be F1 into R, and this torque of this force F2 will be F2 into this perpendicular distance, that is R. So it will be F2 into R, and it is rotating in clockwise direction, so it will be negative minus F2 into R. This is the net torque acting on this ring, will be equals to I about center of mass will be mr square because this is a ring, into alpha. Alpha I have already calculated, it is 3 by 5. Putting the value of F1 as 1.4, F2 I have to calculate this R and this square will going to get cancel out. Putting the value of M, it will be 2, R is given to me as 0.5, angular acceleration is 3 by 5. From here I will going to get the value of friction force offered by this stick on this ring, it will be 0.8 Newton. Okay, now I can write that F2 must be equals to mu1. Okay, now mu for this surface is given to me as P by 10 in question, and normal between these two surfaces, that is the surface of ring and stick, will be this force which is applied by this stick on this ring, that is 2 Newton. So putting the value of N as 2 and F2 is I have calculated 0.8, so P will come out to be 4 over here. So my correct answer to this problem will be 4. I hope you have understood this. Thank you very much.